Hello, as you probably already know, this is an oscilloscope, and in this video I'm going to explain what time base is, how to control the Y gain, what AC and DC signals look like on an oscilloscope, and some ways of analysing AC traces. So, this is the screen of an oscilloscope. It is quite simply a graph with the voltage on the vertical axis and the time base connected to the horizontal axis. You can control the magnitude of time that each horizontal side of a square on the screen represents. Each one of these sides is known as a division. To control this, you simply adjust the time division dial on the face of the oscilloscope to the desired duration. The amount of time per division is known as the time base. Similarly, the magnitude of voltage represented by each vertical division of the oscilloscope can be adjusted by turning the volts per division dial. The number of volts per division is known as the Y gain. On some oscilloscopes, you can completely switch off the time base, which I'll demonstrate later on in the video. In this section of the video, I will show you what DC signals look like on an oscilloscope screen. What I have here is a probe and a 1.5 volt DC battery, and I'm going to connect this end of the probe to the channel 1 input of the oscilloscope. When you press the on button, you will begin to see a horizontal glowing line appear along the x-axis. This glow is produced by a beam of electrons which have been accelerated through a cathode ray tube and collided with a fluorescent screen, exciting the atoms and causing them to emit visible photons as they de-excite again. For this demonstration, I have switched the Y gain to 0.5 volts per division, as 0.5 is a factor of 1.5, making the trace easily readable. The other side of the probe is split into two cables. This one is the main probe and this one is the ground wire. You should always make sure to connect the ground wire to the negative terminal of the battery so that the oscilloscope and the battery have a common ground, and so that when the main probe is connected to the positive terminal, a complete circuit is made and a current is drawn from the battery. As each vertical division is 0.5 volts, what you should see is that the flat line jumps up by 3 squares to a consistent DC input of approximately 1.5 volts. If you remove the connections to the battery and switch the time base off, what you will see is a stationary dot at the central point of the graph. When you reconnect the battery, what you should see is that the dot rises by 3 squares back to 1.5 volts. Three things you need are an oscilloscope, a signal generator which can be used as a substitute for an AC input, and a decent location, like CERN for example. I can now remove the ground wire from the probe, as the signal generator has a built-in ground connection. The signal generator has been set up to produce a sine wave with the following properties: an amplitude of 1.5 volts, a 1 kHz frequency, as we already know, the equation relating frequency to time period is F equals 1 over t, so the time period of this wave is 1,000th of a second, which is equal to 1 millisecond. Horizontally, the oscilloscope has 10 squares, so adjusting the time base to 0.1 milliseconds per division will allow the oscilloscope to display exactly one complete wave cycle of the generated input signal. The main properties of AC signals that you need to know are the peak voltage, which is the voltage reading taken from the highest positive point of an AC waveform, the peak-to-peak voltage, which is the difference in amplitude between the highest positive point and the lowest negative point of the AC waveform, and the time period, which is the time taken for the signal to complete one full wave cycle. If you switch the time base off, the AC signal will be displayed as a vertical line between its positive peak voltage and its negative peak voltage. So, as a quick final recap, the oscilloscope screen plots voltage against time, a division is one side of a square on the screen, the number of volts per vertical division is called the Y gain, the amount of time per horizontal division is known as time base. This is what a DC trace looks like with time base on and with time base off. This is what an AC trace looks like with time base on and time base off.